This is question 8 from the 2011 exam. We need to write the initial tableau for this question using the two-phase method. Now, first step we need to do is, since we have minimize here, we need to turn our problem into a maximize problem. So this will be maximize, and in order to turn it into a maximize problem, we need to multiply the objective function by -1. So we will have minus z equals 5x plus 11y. Now we can actually look at the constraints and introduce the slack and artificial variables. Using the two-phase method, we introduce artificial variables for each constraint that is greater than or equal to some constant, or otherwise we can say that we add an artificial variable for each negative slack variable in our constraint. So here we will have x plus 2y. Since we have greater than or equal to inequalities, we will have one slack variable and one artificial variable for each one of them. So we will have minus s1, since it's greater than, and plus r1, and this is equal to 5. And for the second one, we have 3x plus 4y minus s2 plus r2 is equal to 6. And we have x and y greater than or equal to 0, and we also have si and ri greater than or equal to 0 also. Now, for phase 1 of the two-phase method, we want to maximize w, where w is minus the sum of the artificial variables. So it's minus r1 plus r2. And now we need to express this w with basic variables. So we're going to name this 1 and this is 2. And from 1 and 2 we'll see what r1 and r2 are equal to. So r1 is equal to 5 minus x minus 2y plus s1, and then r2 is equal to 6 minus 3x minus 4y plus s2. Now we can input r1 and r2 into w, and we're going to have 5 minus x minus 2y plus s1 plus 6 minus 3x minus 4y plus s2. Now we will simplify, and we will have 11 minus 4x minus 6y plus s1 plus s2. And this is 4x plus 6y minus s1 minus s2 and minus 11. And we will input w in the form w minus 4x minus 6y plus s1 plus s2 equals to minus 11 into that tableau in this form. So now we have our constraints, we have our objective function w that we introduce for the two-phase method, and then minus z will also be inputted in the initial tableau in this form. So we can actually input all the coefficients in our initial tableau. So we have x, y, s1, s2, r1 and r2. So first we put the basic variables, the slack variables second, and then the artificial variables. So for the first constraint we get the coefficients 1, 2, minus 1, 0, 1, 0 and 5. And for the second one we have 3, 4, 0, minus 1, 0, 1 and 6. Here the basic variables at this stage are R1 and R2. Here we have minus z and then w. So minus z will have minus 5 and minus 11 as the coefficients and 0 everywhere else. And then w will be minus 4, minus 6, 1, 1, 0, 0, and minus 11. So that is the initial tableau. And now we need to circle the entry that we would pivot on. Now we choose the entry that we would pivot on as we did before in the simplex algorithm. So we will go to the biggest negative entry in the W row, which is minus 6 for us. So we have minus 6 as the biggest negative entry. The entry that we would pivot on will be at this column. And now we need to check the ratio 5/2. And then we have 6/4. Now we need to choose the smallest of these ratios, and that would be the row that we would pivot on. So since this is the smallest ratio, then that means we would pivot on 4. This column and this row, 4. And this is the two-phase method.